Okay. So on Friday, we said that if we had a graph, we would use what to determine if it was a function? Yeah, the vertical line test, which we abbreviated as VLT, right? And the vertical line test just says that no vertical line can pass through more than 1 point. It can't pass through more than 1 point on the graph. If it does, then it's not a vertical line. Walter, do you need a pencil? Lapis? Yeah. Up front on the green, yellow, all of those drawers. There are tons of pencils up there. Open one of those drawers, help yourself. Look. Yeah. Yeah. And the little ones. Yep. Yep. Hey, Jacob. Jacob. Easy. Easy down, killer. Okay. Here, look. Pencils. Knock it off. Stop it. Don't do that to me like you didn't see me seeing you do that. I'm not. Stop. You need it sharpened? Is it sharpened? Does it need sharpened?
No.
Okay. All right. Ah! That's the second time I've been hooked. I got hooked on his chair.
No, what was that scream?
I almost lost my pants. That's what that scream was. Okay. Here we go. Shh. We're gonna wait for Walter to catch up. Shh. Yep, we are recording that. That'll be great.
What was the voice recording?
Walter, do you have that information down? Okay, since you're not writing, I'm just going to keep moving forward. All right, here we go. Does the relationship represent a function? Why? Why did you say that? You did a shout out. Why do you think that? Okay, does someone else have a different opinion? -6 is repeating. So this is the equation, and this is the table. All I want you to do when we determine if a table is a function, all we do is look at the domain values. Are there any repeated numbers in the domain? So yes, this is a function because there are no repeated numbers where, Sebastian? Good job. No repeated numbers in the domain. All right, example number 2. Is this graph a function? How do you know? Parker, no, it does not pass a vertical line test. If I draw a vertical line here, touch my graph 2 times, and I'm only allowed to touch it once. Yeah, even right here, right? So no, does not pass VLT. So when you're asked to determine if something is a function, it's not enough to just write yes or no. I want you to tell me why now, okay? You have to say why. Okay. Some of you guys graphed things like this. Does this represent a function? Well, let's go to Desmos Graphing and graph it really fast. What was it? Y equals
3x.
Thank you. Yeah, I didn't put anything. I'm trying to delete that. That was from the last one, but thanks, hon. So y equals 3x. So would that pass the vertical line test? You don't know. Okay, what if I make it really small? It doesn't really look like it's changing. Would that pass the vertical line test? Yes, it would. So yes, passes vertical line test.
Okay. What about this function? Can I graph it? Let's graph it. So that was x equals 3, correct?
Yes.
So x equals 3. Oh my goodness. What kind of a line is that?
A straight line.
All lines are straight. What kind of a line is that?
It's a vertical.
It's a vertical line. So this is important. This is the equation to a vertical line. So would a vertical line pass the vertical line test? Let's go back to that. If I were to draw a vertical line, how many times would I touch that graph? What if I drew the vertical line right here? How many times am I touching my graph? Infinitely many times, right? So does this pass the vertical line test? No, it does not. So it's no, does not pass the vertical line test. So if I drew a vertical line, it lays right over the top of the vertical line that we're talking about, right? So it's going to touch it infinitely many places. Okay. What about this equation? What do you think? You think it's going to pass? Let's graph it. So I'm going to get rid of this one. I have to go back to clear screen. Okay, let's get rid of this function. Maybe. I don't know how to get rid of that little drawing pen now. There we go. Nope. Any ideas? Anyone? There we go. Mouse. Here we go. Thank you. Okay. So let's graph y equals, what was that function? Y equals what?
3.
Thank you.
3.
Okay. So what kind of a line is y equals 3? Horizontal. So would that pass the vertical line test?
No.
Yes, it would. I could draw a bunch of vertical lines and only touch that graph one time. So this is the equation to a horizontal line. And it is a function because it passes the vertical line test. This one does pass the vertical line test. Okay. Okay, so we're going to do 4 or 5 examples together, and then I'm going to give you guys 4 minutes to do 6 on your own. So let's look at this one. Did you still need that, Frida? I'm sorry. So example number 1. Does this relation represent a function? And remember, it's not enough to just tell me yes or no. You have to tell me why. Does this relation represent a function? What do you think, Hayden?
Yeah.
Why? Yes, no repeated terms in the domain. Okay, so after we determine if it is a function, we have to identify the domain and the range. Do you guys remember doing that on Friday? The domain, and then we're going to use the set bracket. We said that the domain had to be written 2 ways. Number 1, we couldn't put any repeated terms in our set. And 2, the order was what? Smallest to largest. So the domain is just the x values, 3, 4, 5, and 6. 3, 4, 5, and 6. Close your bracket. Your range is also a set. Remember, your range is your y values. Again, in order from smallest to largest. And if any terms are repeated, you can't list them. So my range is just 2, 3, 4, and 5. Okay. You guys did this on the who done it activity where you were given the clues if you did the who done it. Okay. What about example number 2? No, who said no? Was that you, Sebastian? Why do you think it's not? Yeah, it does not pass the vertical line test. So this is what Sebastian's saying. He's saying, hey, when you draw a vertical line, you're going to touch that function. That function is going to touch the vertical line 2 times, and that's not allowed. Can we still identify the domain and the range? Jaden, what's the domain? I didn't hear you. Say it again. 1, 2, and 3. Good job. So here's a way to think about the domain. The domain has to come through the X. So maybe draw straight lines where it's going through. So this is when X equals 1, I touch my function. When X equals 2, I touch my function. And when X equals 3, I touch it. Okay. And then I'm going to erase those lines. And now I'm going to figure out my range value. So I'm going to draw horizontal lines. So when I look at my horizontal lines, there are 2 lines, 2 times that the range is used. What are the values of y? What's this value right here? Y equals, and y equals, there you go. Okay. All right. What about this? Is this a function? Yes. We know this because why? It passes the vertical line test. Okay. What's the domain? And what is the range? Daniela, I know that you had something like this on Friday's activity. Remember that this graph is going to go on forever. So what's the largest X value? And what's the smallest X value? That's my domain. Any ideas? You saw the phrase all real, what? Yeah, all real numbers. Your domain is any real number because it covers the whole number line. What about the range? If that line goes on forever, what's the highest Y value I'm going to get? If that line goes on forever, what's the lowest Y value I'm going to get? All real numbers again. Good job. Okay, I'm going to show you something over here. When we see something that looks like this, in parentheses, this means negative infinity and positive infinity. This is the same thing as saying all real numbers. These are the same. Means that your line is going to go as low as you possibly can to the largest number, the largest negative number. We don't know what the largest negative number, it's infinite, but I'm going to put a negative sign on my infinity. And we don't know the largest possible positive number, but I know it's going to be positive infinity, okay? I'm fine with you guys writing this, but you may see this sometimes, okay? All right. Let's look at that. What do I have there? What is that? A circle. Does it pass the function test? No, this is not a function. It does not pass the vertical line test. If I were to draw a vertical line on this, my vertical line would touch that circle in 2 spots, okay? So here's how I think about the range on something that's not exactly perfect. So we're going to imagine that those in-between marks, like if this is 0 and this is 1, where this line comes right here is at 0.5. And where this comes right here is 5.5, okay? And I'm going to write a compound inequality, which we've already seen. So I want to show that the x values are in between 0.5 and 5.5. So my domain is my x values such that I have 0.5 is less than or equal to x is less than or equal to 5.5. Okay, we wrote that before. We've seen that before. You guys looked at an inequality graph, right, to determine that. And then my range, well, what's the lowest that my range goes? That's negative 1.5. And the highest that my range goes is 1, 2, 3.5. So my range is such that negative 1.5 is less than or equal to y, because those are the values that we're talking about, is less than or equal to 3.5. Now, we do have a test coming up. I would not give you something like this on your test where you would have to write an inequality, okay? We haven't practiced it enough, and I just think that that's not fair, okay? So this would not be tested. For Unit 1, okay? Not a testable item for Unit 1. You wouldn't have to know that, okay? Does that make sense? What, hun? Number 5 is not a function. Why do you say that? Yeah, because 3 is in the domain twice. Whoa. That's my hand working faster than my brain. Okay. So could we list the domain? Remember, order from smallest to largest. What do you think? Put it back up there, Sebastian. Jacob, can you tell me what the values, the numbers in the domain are?
0.
Yeah, you're right. 0.
2.
Awesome.
3.
Good job. Perfect. What about my range values? What about my range values? Edward, do you think you can tell me the range values in order from smallest to largest? There's one smaller than negative 1. Awesome.
2 and 4.
Awesome. Negative 3, negative 1, 2, and 4. Okay. All right. I am going to set a 4-minute timer. I'm going to set a 4-minute timer. I want you guys, with whomever is sitting next to you, to talk it out and work out those first 6 that are your first 6 homework. I want you to work them out together.